Hi everyone, I'm glad you could make it. Let's have a look at object role modelling in the aerospace industry. Now, depending on your point of view, there are certainly three primary systems within the aerospace industry that you'd be very familiar with. So there's the rocket launch systems themselves to get payloads into space, and this is certainly the most spectacular area of the aerospace industry. There's the ground control systems, and if you're familiar with movies like Apollo 13, you'd be familiar with ground control systems where computer-based systems and electronic systems and communication systems are used to communicate with, control and maintain not only rocket launch systems but the payloads they carry, whether they be satellites or space probes that go into deep space or to other planets, etc. So there's the ground control systems, and then of course there's the payload itself. So whether it's a satellite or a deep space probe or some sort of space system that's going to another planet or around the sun or something like that. So between those three, these are the primary areas that most people are most familiar with in the space industry. Of course, there's the whole human resources side of things, finance side of things, etc. But certainly the most visible area and the areas that create the most excitement in the industry are the rocket launch systems, the ground controls systems, where we see people jumping up and down and cheering, for instance, in NASA or SpaceX videos when the mission is successful, and the actual satellites or deep space probes themselves. Now, when it comes to object role modelling in the aerospace industry, they're the three areas that I'd like to focus on. And the reasons why is because not only are they the three primary systems that deliver value and end results to end customers, they certainly form the majority of the engineering component of putting satellites, for instance, into space. If you're watching this video, there's a good chance you know exactly why you're here. Is because you work in the aerospace industry and you either work with object role modelling every single day with the work you do in the aerospace industry, or you're someone who's interested in conceptual modelling and object role modelling in the aerospace industry, or perhaps you just want to find out what object role modelling is in the first place. So let's dig a little bit deeper. So to actually get these satellites, for instance, up into space, there's a lot of people involved, and the space industry is a resource-intensive industry that where there's tens of thousands of people, engineers, and all range of professionals who work together to get space systems into space, but not forgetting that they do that to get an end result for their end customer. We're going to be focusing on two aspects, and one is definitely the people who actually work in the industry and who need the right tools to be able to perform their job every day. So if we take, for instance, this lady is working in front of a computer screen. Looks like she's working on a piece of software that's working with telemetry data, and where object role modelling is all about data and the design of conceptual models for data structures, but also in sharing data and being able to communicate data and data structures between people and between computer systems. Now, if she's looking at telemetry data, that could be part of, say, a ground control system, and where there might be what's known as a system reference database, for instance, over which the software operates, and that stores all the telemetry data that comes from a satellite, for instance. The software is one thing, but certainly it's all about the hardware as well. So there's the actual space systems that get put into space, so the payload, and where the hardware and electronics within the payload, so the satellite, including computer systems, also rely on data. Let's not forget though that it's not just about the data, it's about the people who are working to get these space systems into space and to stay there and to look after them in an operational capacity throughout the lifetime of the space system. So I've chosen this picture specifically to show that we're talking about computer systems, hardware systems, and definitely about the people who are involved in putting these systems into space and operating them and maintaining them over time. Once our systems are in space, of course, we know and understand that we're talking about what they do once they're there, and the only reason they're there is to share data between other systems in space, or predominantly sending data back to Earth for the end customer. So that the sort of data we're talking about could be still images, or say temperature data, forest fire images, and maybe even video, etc., that is captured by sensors on satellites and sent back to ground-based systems back on Earth. Of course, systems that go further into space, they too send data back to Earth. Otherwise, there's no point really in sending that probe out there, unless it's gathering data and helping us in some way with the data that's being gathered by the sensors on the machine. But ultimately, we absolutely must focus on the end customer, and it's about happy customers at the end of the day. Now, this isn't going to be a boring, stodgy video, at least in the first part, that you might expect from someone presenting information about serious systems within the space industry. But it's important to fact engine that we remember and don't forget the end customer, and making sure they're happy. So while we might look at this photo and say, well, where's the technology that's making this person happy? Well, let's have a look at another photo. So these people are working with some sort of web-based chat software, and they're having, say, a group conference, and these people might be all over the world, at different parts of the world, communicating with each other and having a group conference, and going about their daily lives, whether they're part of a non-profit organisation or some sort of professional organisation or a company, etc. They rely on technology, and there's a good chance they rely on space systems to deliver the technology and the end result to them, to be able to have their web-based chat. And they too are end customers that we need to focus on and keep happy. This guy down in the bottom right hand side doesn't look particularly happy, but he's certainly in the company of happy customers. There's other customers though. There's the internal customers that actually work in the space industry. So whether they're in finance or human resources, some sort of operational capacity, or systems engineers. These internal customers are equally as important as our external customers, and rely on data as much as the the end customer. So people having a web chat obviously rely on video data being delivered to them. But internally, to get the job done within the aerospace industry, those who work in the aerospace industry need data and conceptual models operating over that data to be able to deliver the space systems to deliver results to end customers. So I've chosen this picture because it's not just a handshake between people with data, but actual computer systems that need to communicate with each other as well. And there's very much an interplay between people and machines, where the underlying grease that lubricates the whole process in the aerospace industry predominantly is data. So we have our external customers and our internal customers, and when we talk about object role modeling and the aerospace industry, I believe that we're definitely talking about making life as easy as we can for internal customers. And what do they need? Well, they need to be able to communicate ideas and concepts and models between themselves. And I've chosen this image because it really captures the essence of what happens within the aerospace industry on a day-to-day basis, where you've got people working together, sharing ideas and sharing concepts and sharing models of whatever it is they're building to make things happen. And it's a very important process that this communication pathway between people is very clear, and that the ideas that are shared in such a way that we reduce the amount of noise, so that mistakes aren't made, basically. Because if we've got, say, a web chat or video conferencing solution that relies on satellites, we'd want to make sure that it's operational, and that it's going to be operational, say, 24/7, 365 days of the year, so that our end customers are happy. I've also chosen this image because when you look at the image, you're saying, well, they're not really people. And it's true that just as much as people need to be able to share and communicate ideas and models and data, the computer systems within the aerospace industry need to be able to share data and data structures and data within the appropriate structure as the grease that lubricates the whole system to be able to deliver results to our end customer. So it's very much a human-machine interface, where just as much as data quite often is mistaken as being about computer systems talking to each other, we can't forget the man-machine interface, where our end customer needs the data, and our internal customers need to be able to work with data, communicate data, and operate over data just as much as the computer systems that they work with, and electronic systems, to make the whole space industry work. So our internal customers, the people who work in the aerospace industry, absolutely need the best tools they can find. And Fact Engine, I believe that object role modeling provides some of the best tools that can be used within the aerospace industry for communicating data structures, for designing data structures, for sharing data structures, and for operating over data structures that is available, and especially in a modern world. And we'll get to very quickly why object role modeling differentiates itself from other conceptual modeling methodologies to be able to offer the most value possible for internal customers working in the aerospace industry. The industry has put a lot of emphasis on what's known as model-based system engineering, and MBSE is exactly that. It's systems engineering to deliver space systems, whether they be ground control systems or rocket launch systems or satellites or deep space probes, so the actual payloads, using models. So there are, or is, a plethora of videos and written material on MBSE on the internet. In this video we're going to stay at a high level because I believe that MBSE can be summed up very easily about what it's about. But MBSE is where the industry is going in terms of having the right tools for our internal customers to use to be able to share data and data structures between not only themselves but also the computer or electronic systems that they work with. And let's not forget that the computer systems that they work with and the electronic systems they work with were all designed by people, by human beings. So it's just as important that people understand the models that they're working with and the systems that they're working with as much as the computer systems that use those models in their operational capacity. Model-based system engineering is becoming a mainstream method within the development of space systems, where there's a lot of emphasis now on designing models and sharing models in such a way that maximizes the ability to be able to quickly and efficiently deliver systems, but not only in the shortest possible time frame, but with the highest possible quality, and where there's a genuine belief that if you get your modeling right, then your ultimate system, whether it be a computer-based piece of software or a piece of hardware, with the model right, the aim is to get the system right such that the end result is as reliable as possible, and where I believe that the emphasis is on an end degree of high quality, and where quality can be measured in many ranges, but the space industry relies on the highest possible quality, such that systems, once they're in space, are maintainable and have a long life span, because we all know we just can't get up into space to fix satellites, etc. Easily, or if at all. So things have to be done right the first time. So it's all about our internal customers when it comes to things like object role modeling and conceptual modeling and MBSE, and where if these people have the right tools, then the results for our external customers are going to be there. And those tools provide a mechanism to be able to share and communicate and design conceptual models, and where the ability to share those models and designs is not only between people but also computer systems, and as part of MBSE, the software that delivers the models in the first place, that the engineers use to design the models. So sharing models between systems that are used to make or document models in the first place. And that's where object role modeling comes in. So object role modeling is a type of conceptual modeling that has two primary components. It has a graphical component, so a graphical notation, but it also has a natural or controlled natural language component known as verbalizations, and where together the graphical notations and sentences in the controlled natural language define an object role model, and where object role modeling is a type of fact-based modeling and also a type of semantic modeling, and with stress on semantics because it is arguably the most semantically verbose conceptual modeling language in the world, where it has an emphasis on controlled natural language descriptions of the underlying data structures and constraints that operate over those data structures. Very soon we're going to look at a conceptual model taken from the space industry, so from the aerospace industry, and dive right into object role modeling. I'll keep it at a high level for now though, as we explore more about what object role modeling is about. We've come a long way from entity relationship diagrams, say from the 1970s for instance, where conceptual models might have had a little bit of semantic information in them, so some predicates in the foreign key relationships between entities, where today there is a really strong emphasis on being able to communicate models using as much or with as many semantic tools as possible, and natural language being among them. So for instance, this is a part of a business vocabulary and business rules that comes from the data model or the conceptual model that we're going to look at in object role modeling for a element of maintaining space systems, and where if we're looking at, or if we think back to where we've got satellites going around the Earth and where they're sending data back to Earth, for instance, we can think about packets of data, and where we might have something known as a packet store that stores data, and where we have a list of business rules in natural language that help us define or form a model in our heads as to what a packet store is. And for instance, we might look at these couple of lines here where we read each packet store transmits its packets over one virtual channel, and where a virtual channel possibly is used by more than one packet store. So that gives me a bit of information about what a packet store is, and it's easy to read, it's in natural language. I can picture a virtual channel where I've got a channel between, say, a ground-based system and a satellite, and where the packet store transmits its packets of data, that makes sense, over one virtual channel. But let's say I don't even know what a packet store is. Then if I'm a systems engineer and I've just joined the aerospace industry and I've just joined a team that's designing and developing a satellite, I might want to know more about a packet store. Now, where we're moving to in the industry is where metadata provides not only natural language descriptions, but also descriptions in natural language, maybe even in an informal way, of what a packet store is. Now, just for example, I'm going to jump out and have a chat with a quasi expert who's trolled the internet to find out things about packet stores, and that's ChatGPT. So let's ask ChatGPT about packet stores. So in the aerospace industry, what is a packet store? Let's see what it comes back with. So it's come back and it says, well, I couldn't really find anything about packet stores in the aerospace industry, but it says the term packet typically refers to a unit of data transmitted over a network, often used in computer networking and telecommunications. A packet typically contains a header, etc. Now, in our systems that operate over our metadata, we might want to store information that gives us a precise description of what a packet store is. And so the tools that object role modeling uses allows us to store even that high level informal description, as well as these low level formal descriptions of our data structure and our what are known as object types within our conceptual model. So if I'm an engineer within the aerospace industry and I'm using a tool using object role modeling, I'm starting to form a model in my head as to what a packet store is, for instance, and the way that packets of data are shared, say, between satellite systems or back down to Earth to a ground-based system. So we've formed a model that our satellites have a packet store that stores packets of data that are sent via a virtual channel, say, to a ground-based system, at least in this definition within the conceptual model or the universal discourse that we're looking at the moment. Imagine this. Imagine the various ways that data is used in the aerospace industry. So on a satellite itself, you might have a whole range of sensors that locally store data, and so for instance, let's say temperature data, for instance, that they want to send back down to Earth. Now those sensors might store that locally. The satellite might have a system whereby that satellite data, that sensor data, is collated into a packet store and sent back down to Earth. So that's one way of looking at the types of data that we need to have adequate control over using conceptual modeling. But also, if we think about a rocket launch system, it too might have a whole range of sensors that send their sensory information, so how the rocket launch is actually going as it's being launched into space, send that to a packet store, which sends, say, telemetry data back to a ground-based system on Earth. If we think about a ground-based system, the ground-based system might have various antennae, is that how you say it? Antennas around the world, and where the various antennas collect information, channel them to a central database, and where that central database stores a whole bunch of telemetry data from the satellites and as gathered by a ground-based system. So once again, the aerospace industry has the grease of data at every step along the way within the three primary systems that we're focusing on and that most people relate to, the ground-based systems, the rocket launch systems and the satellite systems, and where object role modelling is used to both do two things. So design and document the conceptual model for that data as it is used by internal customers, but also our external customers. Let's not forget our external customers, who are the most important customer. Now, because object role modelling is so semantically verbose, FactEngine says that it provides a semantic view over those particular data stores, and we're using the semantic information within an object role model. The object role models can be used to generate documentation, so PDF files or web pages or Microsoft Word documents or something like that, where the natural language rules are expressed to the end reader of the document, but also we can put in those documents graphical diagrams which describe the model as well, the conceptual models. The object role models are used to communicate and share concepts or the conceptual models between people, but also computer systems. So object role models can be exported as, say, XML and shared between various tools, and we'll have a look at where that has been done today, and or computer systems, other types of computer systems. So the object role model becomes a tool for sharing information about models between people and computer systems, and where the actual, say, telemetry data, so the actual data that is consumed by internal and external customers, can be designed, and that's why I've got this little ER diagram down the bottom here. An object role model can be used to design the ER model for a database that stores, say, telemetry data that is sent back down to Earth for, say, the ground control system to operate the data, or to store the data that is forwarded or on-sold to our end customers. So object role modelling is used for documentation, communication and design, and where design isn't just limited to design, it's design, build and test, implement all those three or four layers, all use object role modelling in the aerospace industry to design, build, test and implement and maintain operational systems in the aerospace industry. So without further ado, we'll actually start looking at object role modelling over a model provided to us from one of the largest organisations in aerospace, and I'll move over to showing you that inside an object role modelling tool. And give me 2 secs, I'll be straight back with you to do that.